When Jim mentioned that it looked like the audience was full of lions, it reminded me of some, I think, bad advice I gave. That for a speaker who's nervous, they're supposed to imagine that the audience is naked. If Jim thinks lions are scary.
Naked lions. Pretty frightening for some audience.
Well, as Jim Tiemann mentioned earlier, one of the goals of the Jove program is to try and move toward doing scientific measurements. And that means making quantitative measurements. It's one thing to, and it's a good step, you know, for someone who's built their first radio receiver and put up their first antenna, to pick up signals from the sun or Jupiter, and it's pretty exciting. But then you go to compare it with somebody else, and maybe they had their gain control set differently, or they had a different kind of antenna, and their spike is great big and yours is little, and you feel bad. Or it's the other way around. So it's really important to calibrate the system so that you have an understanding of what the real digital values of the data are, and where you can make comparisons. So calibration allows the quantitative measurements, and of course allows us to measure how strong the signals are that we're receiving. And another important benefit is that we can determine how radio quiet our receiving side is. And I think all of us at one time or another have had some issues with how quiet or noisy the receiving side is. The background noise, or the noise that you pick up on your antenna when you're not listening to a station, is generally from two sources. There's good noise from the galaxy, and that's, as I mentioned earlier, from relativistic electrons spiraling in the galactic magnetic field. And then there's the bad noise. And there's all kinds of bad noise. Like in Honolulu, they specialize in arcing power lines. And if you live near the ocean, that's going to happen. Automobile ignitions, lightning, electric motors, computers, fluorescent lights, you name it. There are a lot of sources that can raise the noise floor up. Some of them are very short-lived, and some of them just garbage there all the time that raises the whole noise floor. So you want to be able to determine if you've got a good quiet site, or which would be a site where the predominant amount of noise is from the galaxy, and a minimum amount of noise from your neighbor or whatever else. Well, let's just real quickly go through them. The Jove receiver audio output, you'll learn which button to hit. You can take the audio output of the receiver and go to a meter, or you can go to headphones, or you can go to an oscilloscope, or you can go like most all of us do, plug it into the sound card of the computer where it's digitized, and then goes to Jim Sky's excellent software where we can generate a strip chart from it. Now, out of the box, and I guess this is where the SkyPipe unit thing came from, they're relative units. They're not volts or watts or furlongs per fortnight or any of the other common units we use. Power, antenna temperature, flux density, some of the ones more common to radio astronomy. So it's useful, but it's more useful if we can do a calibration and come up with a vertical axis in terms of something called antenna temperature. Because with this, you can change the trace by changing the receiver gain or by changing the software gain, and you don't really know where you're at, what's a big signal and what's a small one, unless you've got a reference. Jim processes the data coming from the sound card and samples it, and then computes the absolute values and squares it and integrates those together. So I think if I get this right, Jim, about every 1,000 samples coming off the sound card results in one plotted point on the...
Well, it depends on how many samples. It divides up a second into the number of samples you want per second, and then plots all the sound samples coming from the card within that bin.
Yeah,
So
more or less. That was right.
that's totally confusing, I know.
So it's normalized and plotted as something that's proportional to power when you're using the power detection mode. So again, the amplitude calibration will convert this relative scale into an absolute scale. So, it's like with a thermometer. I mean, you can say it's hot, or you can read it's 78 degrees or 110 degrees. We want to convert it into some absolute numbers. On the space side of an antenna, is our antenna with so many square meters. Wes talked about the effective area. This is the size of the bucket we're using to collect power from the source. We have flux density, which is the number of watts per square meter per cycle of bandwidth that the radio is admitting through it. And it generates power at the antenna terminals. And there's an equation P equals KTV, which I've rearranged to write in terms of antenna temperature. The IF bandwidth of the receiver is the term B, and K is Boltzmann's constant. So, try again, back in the desert.
That's Russel.
I knew somebody was going to do that or wrote my name on it. Maybe it is. If we take a receiver, and in this case, just to give a little change of pace, I used an ICOM R75, which several of the folks use. And we take a 50 ohm resistor and hook it onto the input and the antenna terminals. We can compute the resistor's got some electrons wandering around in there, and at any one instant, there might be more electrons on one terminal than on the other terminal, so it develops a little bit of voltage across the resistor. And that number of electrons and how fast they're moving and the voltage is determined by the temperature. Put more energy in there, they're flying around a little faster, get more voltage. That's more power. So this is the power delivered from a source to a matched load is given by P equals KTB. If the bandwidth of the receiver is, say, 7 kilohertz and we're sitting there at room temperature, 290 degrees Kelvin, the power that's delivered to the receiver is about 3 times 10 to the minus 17 watts. A pretty small number. Or for those of you that like voltage, it's about 37 nanovolts, and that's minus 135 dBm. Everybody likes different units of this sometimes. Now, let's take and heat that puppy up a little bit, and we'll raise the temperature up to, say, I don't know, 50,000 degrees with a blowtorch. And now we're generating quite a bit more power at the antenna terminals. Now it's 10 to the minus 15 watts, half a microvolt. It's about 20 dB stronger as we heat the resistor up. Well, if we take our coax coming out of the radio, and in one case we have it hooked to the resistor that's getting abused by the blowtorch, and then we switch it over and hook it up to an antenna, we're going to measure just about the same signal coming out of the receiver. And you can say, well, okay, then the antenna acts like it is a 50,000 ohm, 50,000 degree source of radio noise. So we call that the antenna temperature. That's kind of where that term comes from. And it turns out to be a good, useful term to use, and that's, in fact, the term we will use to calibrate the vertical scale of skypipe. Now we got this fellow over here. Jim stuck him in the program. It's called the Calibration Wizard, and there's a sequence of steps you go through with a calibrator, and that will convert the vertical scale of skypipe to antenna temperature. And I think, Jim, you're going to give us a live demo if we get done?
Yeah, check.
You got 6 minutes.
6 minutes, okay. Maybe will, maybe won't. Okay, basically, take the receiver, stick the calibrator here. With the power switch off, the antenna is connected directly through the calibrator to the receiver. Turn the calibrator on. This is a noise source. It's not at 50,000 degrees. There's not a little blowtorch in there. It's only at 25,000 degrees. And we have to tell the Cal Wizard about that. And this is what the calibrator looks like that Jim Tiemann mentioned that you can obtain on the Jove site. There are a couple other calibrators that are available. One of them, surprisingly enough, is a Hewlett-Packard low noise amplifier that generates 72 million degrees. That and a step attenuator make a very good calibrator for the lab bench. And there's one that I've made a couple of these also. So this is what a calibrated record looks like with antenna temperature in kilokelvins, thousands of degrees Kelvin. And this is from Jim Brown. You notice the noise floor is down around 80,000 degrees, so he might have had a little local noise in there. And then we've got a calibrated reading on how strong all of these bursts are, and that's it. And so,
Okay, we'll try this really quickly. I just want to show you that it's not that hard to do. It doesn't matter. Oh, well, yeah, I don't know how to use that either. Okay. So, let's say you're we have a Jove receiver here. We have the calibrator that we've been talking about, and we don't have an antenna, but that's all right. Normally, you would have an antenna. Power has to be applied to both of them at some point here. You go to Tools when you're ready to do this, and you click on Calibration Wizard. And this just reminds you that you need a calibrated noise source to do it, in case, and that's for someone who's not trained like you all are about it. This is a multiple channel chart, so it asks us which channel, and it's this on number 1. I don't know why that is like that. You drag this over here. But what it's saying here is make sure that your microphone or your input source is what you think it is. Here we're hooked up to a little dongle and the input of that. Yes, okay, we're good with that. So now we turn off the power to the receiver. I'm going to actually unplug the transformer because it makes less racket. And I think I've got this thing plugged. No, I unplugged it. Okay, turn off the power to the receiver, press OK. This screen is kind of odd. It's a little B screen. And, okay. What it's doing now is it's just going through and measuring the sound card with no input at all. That's because some sound cards are really crappy, and the little ADC on them will put out some value. Could be anywhere from 10 to 500 or 600. That always feeds to the program, and you don't want that to get added into your data. Now it's taking care of that, and it wants to know whether you're using the standard dual dipole or you've got your own antenna set up, and the losses between the antenna terminals and the back of the receiver. So let's just say we're using the standard thing here. This is the standard setup with RG59. I thought it was RG6, but it's RG59, and normally they give you a tail of 16 feet. Although you might increase that amount if you've added onto it to get it into your radio room. This tells you that the loss between those antenna terminals and your receiver is 1 1/4 dB. Now you want to put in the temperature that of your calibrator. This calibrator is 25,000 degrees, and you put it in K. So that's, you put 25 in there. Now then, we apply power back. Okay. There's that annoying screen. And what we want to do here, which we can't do because for some reason it's maximized my, here we go, I'm going to try to move this down. Yeah, we're already in a good range, but what we want to do here is adjust the volume and also or adjust the input level on the mixer down here at the bottom to get within a range around 200 to 800, something that the computer can work with. So you're actually...
Change that to 70, just to see what happens. 70%.
So now we're feeding more signal into SkyPipe through the mixer. You could also adjust the volume. So here, you'd like to keep this around noon so you can keep your most dynamic range, like Dick was talking about earlier. Once you get that just in that wide range there, click OK. And then now it's doing its magic. Okay, and so you can see it thinks, okay, we're at, well, it's showing, it was showing 25,000 on there. However, now if we start the chart now, and we've still got the calibrator hooked up, remember, not our antenna. Oh, it's way down there. Let's get it up here a second. It's gonna read above 25,000 because it thinks that there's loss in this signal coming through from the antenna, and it's compensating for that. So that 1.25 dB is getting added back into the estimated signal from your antenna, and that's it. That's your calibration process.
I have the dummy load. You don't need to do that when you've got your antenna disconnected. I just put 50 ohms on the connector.
It's not making it through that.
Oh, it's not.
It's not, no.
All right.
And at any point we're actually I've got it turned on, so it's coming from the noise source at this point. Now it'd be coming from the antenna, which doesn't exist. So.
All right, thanks, Dick. Thank you. Any questions before we break? Yeah.
Well, I'd like to point out how nice the Calibration Wizard is. Some of you have seen me make presentations at the Sarah conferences before. And a number of years ago, I did an entire half-an-hour presentation on the old way to calibrate SkyPipe, which was using a step noise source. Then you'd have to get the average of all of those steps. Then you'd have to feed that into Excel. Then you'd have to do a plot. And then you'd have to take the plot and come up with curves, the curves for that. Then you'd have to take that value out of Excel and plug it back into SkyPipe in the formula section, and then you could be calibrated. So that would take half hour, 45 minutes to go through all of that process to get calibrated. With the step calibrator, man, it is just a dream. So big kudos to Jim for the calibrator, because that has made life so much
Then I have a question. Why does it work this way? Because on regular radio telescopes in this frequency area, you do as you are telling.
They worked it out, not
So
me.
is it because you recheck that you are in the linear range and you don't care about any change of the... Is it because of the linearity of that you assume? Or?
It's a linear response in the radio over 40 dB range. So the calibration is good over that range unless you turn the gain control.
Yeah.
And that was the point I wanted to make is, this works great on a Jove receiver, but if you are using, say, an AM receiver and just disabling the AGC, I'm not going to guarantee what the linear dynamic range is. So you need to go through that long, tedious process that Jim just described of using a multi-step calibration to understand what the response curve of the radio looks like, and then go in Excel and file those gains to get a correction equation to plug into SkyPlane.
I use the ICOM R75, and I did calibration talking about with the 60 million degree calibrator. But in general, the ICOM is pretty consistent. So if you set the gain, the RF gain, and the audio gain to a certain position in the dial, it worked pretty well. So I could give anybody who's got the ICOM an area to start from at least, where you keep linearity without, if you don't have the big calibrator. If you have the big calibrator, that can do that.
Question?
What's the latest version of SkyPlane?
Latest version of Skype.
2.6.13.
And that's the one you would download if you go to your website, correct?
No, of course not.
I do several updates, and then I'll update the main download. So you'll have to do, an update, which is it just replaces the exe file. And, but that file is still on the website.
Any other questions?